third graders. It's Miss Street. I hope you're having a great day. It's beautiful and sunshiny, but it is a little cold. Miss Street thinks it's cold. All right, you ready to subitize? Remember, Miss Street needs you to tell me the two factors and the product. And this is a really great way to help us not memorize math facts, but understand what is called the commutative property of multiplication. Okay, here we go. Six groups of two. What are the factors? Miss Street disagrees with this slide just a little bit, but it says the factors are 3 and 2, or 6 groups of 2 dots, but that gives us 12 dots. So it's saying three groups with 2 and 3 groups with 2. This music is groovy. Here we go. Seven groups of 2. What does that give us? 14. Eight groups of 2. That gives us repeated addition. 2 plus 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 2. I think I said that 8 times. 16. Good. One more. Oh, good grief, Miss Street. Ready? Here we go. Nine groups of 2. And what is that? 18. Hey, Deegan. Thanks for joining Miss Street today. All right, guys. We're going to move on in our fraction work. And let me tell you something right now. Whew, it's serious. But a good thing about it is that we have, it's down here. I don't think it's going to fit. That'll work. We have already laid the groundwork for this. So we're ready to go. We are going to be talking about 3.MD.3. Represent equivalent fractions with area and length models. And remember, Miss Street's been preaching that equivalent means they have the same area. For instance, 1/2 has the same area as 2. Miss Street can do this. As 2/4. They cover the same amount of area. Okay, that's what equivalent means. Okay, we're going to talk about, and our length models. We all remember that's a number line. That's right. And we're going to really be working on some vocabulary, composing, decomposing, and we've talked a lot about related fractions. So we're going to drive that home today. Okay, so if you remember, Miss Street's going to move my camera just a little bit closer. I think. I don't know. I might knock something off. And if I do, that's okay. That's fine. Here we go. All right. There we go. That's a little bit closer. Okay. So in this standard, we have to make sure that we understand that if the numerator, which means the equal parts we're talking about, is the same as the denominator, which means all the equal parts, that they have the same value as one whole, okay? And so what that means is there are numbers and there are quantities that are less than 1, okay? And so in this model, that means we have 1/4, 2/4, 3/4, and 4/4. When I color in all equal areas, all the equal shares, equal parts, I have one whole, okay? In this standard, we also have to look at whole numbers only up to the whole number 4. So that means 0, 1, 2, 3, 4. And to me, Miss Street thinks this is very, 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 very difficult, okay? So I'm going to try to explain it the best way that I can. But it's important for third graders to really lay this foundation. Teachers, when you're teaching fractions, to lay this foundation so firmly, because this is what helps students with division and also in 5th grade math with division of fractions. It's big. So I don't think we talk enough about this one. So Miss Street may spend a few days on this guy right here, okay? So fractions, whole numbers up to 4 as fractions. And so Miss Street made a length model. It's also a number line. And it is a length model up to how many whole numbers? 3. In 3rd grade, we only work on this standard through 4 whole numbers. So I could have actually went 0, 1, 2, 3, 4, but I just went to 3. Okay. And if we look at this, Miss Street has partitioned each whole into equal areas. So what are the equal areas that Miss Street has partitioned? Let's see. I really want to put it into a story, because when we we give context to things, that really helps us. So I want to make sure that I get it right. Okay. So let's say that we have, Miss Street's just going to show you, and then we'll add a story. Okay. Okay. So let me move this up just a little bit. Okay, so here you can see Miss Street has each whole partitioned into, this is 1 equal area, 2 equal areas, 3 equal areas, 4 equal areas. So I partitioned each whole into fourths. So this one whole is in fourths, this one whole is in fourths, and this one whole is in fourths. So let's label that. And this is what Miss Street means by whole numbers as fractions, okay? We got to look at them as fractions that are greater than 1. So here we have 1/4, 2/4, 3/4, and we know the 1 whole is 4/4. We showed that over here with our area model. Can you see? All right, now I'm going to keep going. So I'm at 4/4. If I have another fourth, that's 5/4. 5/4, 6/4, 7/4, 8/4. I know Miss Street's blowing your mind right now, and that's okay. But Miss Street wants you to know that this is very important, 3rd graders, that you know how to do this, okay? Do you see what I've done? And do you see how that works with division? I'm going to give you a moment to look at that. Look at the 2. Or you could do it with the 1 too. All right, I'm going to keep going. So I'm at 8/4. If I add another fourth, what is that? 9/4, 10/4, 11/4, and 12/4. Okay, that's what it means to look at whole numbers as fractions. And again, we only use the whole numbers up to the number 4. Okay, so 12/4 is greater than 1. Why is that? Because 12/4 has the same value as 3. 8/4 is greater than 1. Why? Because 8/4 has the same value as 2. And 2 is greater than 1. Awesome. Okay, so we're going to keep those things in mind, and we're going to start a problem today. I hope we can get finished with it. We might, and we might not, and that's okay. I just want to keep in mind that you remember related fractions, and remember that a related fraction is a multiple of the fraction that it's related to. So we have 1 whole. We know that 2 halves have the same value as 1 whole. We know that, I'm just going to lay it on top, 4/4 have the same value as 1 whole. We know that 8/8, these are a little messed up. have the same value as 1 whole. So we're really looking at this part that we're supposed to know too. But we also know that halves, fourths, and eighths are related, and they're related because they are multiples of each other. So we have half. If we take half and partition it in half, that gives us our fourth. Perfect equal areas. Then if I take my fourth and I partition it in half, that gives me an eighth equal area. So that's why these are related. So we need to also look at fourths and thirds. They're not related because they're not multiples of each other. We can't find one within the other, okay? But I want you to understand that 1/3 and 1/6 are related fractions because we can take this 1/3. Do you remember how we got to 6? We partitioned it in half. So if we take this 1/3, partition it in half, guess what it gives us? 1/6. Those are called related fractions. So Miss Street went deep with that just a little bit. I do have a word problem, but I think it's going to take me longer than the time that we have. So we'll start with it tomorrow. The biggest thing in this standard Miss Street's going to preach, is that you guys need to understand whole numbers up to 4. And again, that's 0, 1, 2, 3, 4. Get your feet on the floor. Gotta get up, get down. Okay. I had to do it, sorry. So whole numbers as fractions. So 8/4 is greater than 1 because 8/4 has the same value as 2. We could also look at 9/4. You'd think by now Miss Street would be able to do this. Okay, 9/4. That's 1 more fourth than 2, isn't it? So it's like 2 wholes and 1/4. But we say it as 9/4, 10/4, 11/4, 12/4. And again, we do that up to the number 4. So we can partition each of these into halves, fourths, thirds, sixths, and eighths, and do the same thing. So each day Miss Street might do a different one of those. So you can really see how fractions can be greater than 1. Okay, so Miss Street hopes you guys have a great day. I'll be with you again tomorrow. I love ya. Tomorrow, Jess is going fishing with Mason. He is your cousin. Okay, have a great day. We'll see you tomorrow.